Walk onto the factory floor of the Detroit Arsenal Tank Plant in Warren, Michigan, in the winter of 1942, and you would witness a staggering display of American industrial capability. Assembly lines stretched into the distance, moving with a synchronized mechanical rhythm that defied imagination. Giant overhead cranes hoisted cast steel turrets, while thousands of workers mated massive engines to welded lower hulls. Out of these sprawling facilities rolled the M4 Sherman medium tank. By the time the industrial effort concluded, American factories would churn out nearly 50,000 of these vehicles, creating a logistical tidal wave that equipped not just the U.S. Army, but British, Canadian, and Soviet forces across the globe. It was an absolute triumph of mass production. But hiding beneath this miraculous output was a glaring, profound paradox. As the United States mobilized the greatest industrial machine in human history, it deliberately committed its frontline armored forces to a vehicle that was fundamentally outclassed in direct combat. The U.S. had the steel reserves, the metallurgical engineers, the high-octane fuel, and the heavy manufacturing base to build practically anything. Yet they knowingly standardized a 30-ton medium tank armed with a short-barreled 75mm gun, despite rapidly mounting intelligence that the enemy was fielding substantially heavier armor. If you want to keep untangling the real engineering history and the hidden doctrinal decisions behind the great conflicts of the 20th century, subscribe to join us as we explore these historical deep dives. To understand the scale of this engineering paradox, you have to look at the ballistic and structural realities of the era. The standard M4 Sherman was designed with a sloped frontal armor plate that measured approximately 51 millimeters thick. Its main armament, the 75mm M3 gun, was a reliable and highly accurate weapon, but it was a low-velocity gun. It was engineered primarily to deliver a high-explosive shell, lobbing an arc of steel and explosive filler to neutralize infantry positions, pillboxes, and soft-skin transport vehicles. It was an excellent infantry support tool. Across the Atlantic, however, German engineers were operating under a completely different set of assumptions. Discarding their pre-war weight restrictions, firms like Henschel and Krupp were developing armored behemoths specifically designed for mechanical dominance. Intelligence reports from the Eastern Front were already whispering about the Panzerkampfwagen 6 Tiger, a vehicle that tipped the scales at over 50 tons. It featured heavily armored vertical plates measuring 100 millimeters thick on the front hull. More importantly, it was armed with an 88mm anti-tank gun, a weapon of such high velocity and kinetic potential that it could easily overmatch standard Allied armor at extreme ranges. Soon after, the German Panther tank would emerge, bringing 79 millimeters of heavily sloped frontal armor and a lethal, high-velocity 75mm cannon of its own. Think about what that ballistic mismatch actually meant for the crews inside the vehicles. If an American M4 Sherman engaged a German Tiger at a standard combat range of 1,000 meters, the Sherman's standard M72 armor-piercing round would strike the Tiger's face, harden Krupp steel, and simply shatter or deflect. The kinetic energy was mathematically insufficient to achieve penetration. When you reverse the engagement, the physics become grim. An armor-piercing shell fired from the Tiger's 88mm gun possessed more than enough kinetic energy to effortlessly punch through the Sherman's 51mm frontal plate. Such a breach resulted in immediate structural compromise, catastrophic overpressure within the crew compartment, and the highly probable ignition of the onboard ammunition stores. A direct hit almost always guaranteed a fatal outcome for the vehicle and heavy losses for the crew. This was not a secret. The math was known. The intelligence was verified. So why did the American military deliberately handicap its own armored divisions? Stay with me here. This is where the official narrative begins to fracture. It is a common misconception that American engineers simply lacked the technical capability to design a heavy tank. That is completely false. The US Ordnance Department had heavily armed concepts already waiting on the drafting tables. Early in the mobilization effort, American engineers actually developed the M6 heavy tank, a massive multi-turreted design that featured 3 inches of frontal armor and a powerful 3-inch main gun. Furthermore, American ballistics experts had high-velocity 90mm anti-tank guns in their arsenals, weapons fully capable of defeating heavy German armor. The decision to freeze the design of the M4 Sherman and suppress the mass production of heavy American tanks was not an industrial accident. It was a deliberate, calculated, top-down choice dictated by the War Department. Look at what the declassified procurement records and internal memos show. The highest echelons of the U.S. military looked at the heavier, more lethal designs proposed by the ordnance engineers and actively rejected them. They commanded the assembly lines to keep building the medium Sherman. Part of this decision was cloaked in the cold calculus of global logistics. The United States was fighting a two-front war across 2 massive oceans. Every single piece of equipment had to be loaded onto a Liberty ship, transported thousands of kilometers across hostile waters, unloaded at primitive or heavily damaged port facilities, and driven across temporary pontoon bridges. A 30-ton M4 Sherman fit neatly into the holds of a standard cargo ship. The cranes at the docks could lift them without snapping cables. Standard railroad cars could haul them without exceeding track gauge limits or collapsing bridges. When military planners looked at a 60-ton heavy tank, they did not see increased combat survivability. They saw a logistical nightmare. A heavy tank consumed twice the shipping space, required twice the fuel, and threatened to break the specialized Bailey bridges used by combat engineers. By standardizing the medium tank, the United States guaranteed high operational readiness and overwhelming numerical superiority. But if you think prioritizing transatlantic shipping weight over frontline combat survivability is a cold calculation, look at the tactical framework the military built to justify it. Logistics alone cannot explain why the Sherman was restricted to a low-velocity gun when a better weapon could have been fitted to the same 30-ton chassis. The underlying reason the American tank crews were handicapped goes far deeper than shipping cranes and railroad gauges. It was rooted in an untested, academic military doctrine that fundamentally misunderstood how armored warfare would unfold in the European theater. The highest-ranking ground commanders in the U.S. military operated under the rigid belief that a tank should never be used to fight another tank. According to this overarching strategy, the tank was viewed essentially as mechanized cavalry. The role of the armored division was to wait until the infantry punched a hole in the enemy defensive line. Once the breakthrough was achieved, the medium tanks would pour through the gap, operating entirely in the enemy rear, disrupting supply lines, destroying communication hubs, and outrunning any heavily armored response. Speed, mechanical reliability, and operational tempo were considered far more valuable than thick armor plating or armor-piercing firepower. But what would happen when the enemy inevitably counterattacked with their heavy panzer divisions? Under this strictly segregated doctrine, the M4 Sherman was ordered to avoid the engagement entirely. Instead, they were supposed to call upon a completely separate branch of the military, a specialized force equipped with fast, lightly armored vehicles carrying high-velocity guns. This specialized branch would be tasked exclusively with hunting down and neutralizing enemy armor, leaving the medium tanks free to continue their exploitation maneuvers. It was a perfectly clean, academically sound theory drawn up in the safety of the War Department offices. It neatly divided the responsibilities of the battlefield, turning chaotic, mechanized warfare into an organized, heavily regulated system. But military theories rarely survive contact with the enemy. To force this doctrine into reality, a powerful bureaucratic machine had to silence the dissenting ordnance engineers who warned that dividing tanks from tank killers would end in a tactical disaster. The American military was about to send thousands of young crews into combat in undergunned machines, relying entirely on a theoretical framework championed by one specific, highly influential general who refused to believe his vision was fatally flawed. The man responsible for imposing this rigid, academic framework upon the frontline armored divisions was Lieutenant General Leslie J. McNair. As the commander of Army Ground Forces, McNair held unparalleled bureaucratic authority over the organization, training, and equipping of the entire American ground military. He was an artillery officer by trade, a brilliant logistician, and a man fiercely dedicated to efficiency and order. When he looked at the sprawling, chaotic, mechanized battlefields of Europe, he sought to impose a strict division of labor. McNair fundamentally believed that the German blitzkrieg, the rapid, concentrated, armored spearheads that had just fractured the French and British armies in 1940, could not be stopped by building heavily armored defensive tanks. In his view, using a tank to fight another tank was an inefficient waste of resources. It violated his core principle of offensive mobility. Instead, McNair envisioned a completely segregated tactical universe. The 30-ton M4 Sherman was classified strictly as an exploitation weapon. Its job was to wait in reserve, cross the line of departure only after the infantry had shattered the enemy defenses, and wreak havoc on soft, logistical targets in the rear. To deal with the inevitable counterattacks by heavy German panzers, McNair ordered the creation of an entirely new, independent military branch, the Tank Destroyer Force. Look closely at the declassified field manuals drafted at the Tank Destroyer Center at Camp Hood, Texas in 1942. Field Manual 18.5 explicitly outlined the operational doctrine. Tank destroyer battalions were not to be tied down to infantry or scattered across the front line. They were to be held as a massive, highly mobile reserve. When enemy armor breached the line, these specialized battalions would act like a mechanized fire department, rushing to the sector, utilizing natural cover to ambush the heavier German tanks, and immediately relocating before the enemy could bring artillery to bear. To execute this hit-and-run doctrine, the hardware had to match the theory. Ordnance engineers were tasked with designing a vehicle that prioritized extreme speed and high-velocity firepower over everything else, including crew protection. The result was the M10 Wolverine. Built on the reliable lower hull and drivetrain of the standard M4 Sherman, the M10 was structurally modified to fit the tank destroyer doctrine perfectly. Its armor was stripped down and steeply sloped to save critical weight. More importantly, it featured a distinctive open-top turret. This was not a design flaw or a manufacturing shortcut. It was a strict requirement written directly into the procurement requests by McNair's staff. The doctrine dictated that tank destroyer crews needed maximum situational awareness. An open roof allowed the vehicle commander an unobstructed 360-degree view of the battlefield, enabling him to spot enemy armor through binoculars long before the heavily enclosed German panzers could see them. Inside this open turret, engineers mounted a high-velocity 3-inch anti-tank gun, a weapon far superior in armor-penetrating capability than the short-barreled 75mm cannon mounted on the Sherman. But this rigid specialization came with a massive hidden cost. Because McNair had officially assigned the role of armor hunting exclusively to the tank destroyer branch, he deliberately restricted the capabilities of the standard medium tanks. Stay with me here, because this is where the bureaucratic friction turns into an engineering tragedy. The US Ordnance Department fully understood that the Sherman would eventually have to defend itself against heavier enemy vehicles. Long before American troops set foot in Europe, ballistics engineers had already developed a much more powerful, high-velocity 76mm gun that could fit into a modified Sherman turret. They repeatedly petitioned the War Department to begin upgrading the medium tank fleet. McNair actively blocked them. Declassified internal memos reveal that McNair and his staff at Army Ground Forces continuously rejected the 76mm gun upgrade for the M4. Their reasoning was strictly doctrinal. McNair argued that if you gave a Sherman crew a high-velocity anti-tank gun, you would encourage them to actively hunt enemy armor. If they started hunting enemy tanks, they were abandoning their primary mission of infantry exploitation, thereby ruining the carefully choreographed division of labor. The Sherman was ordered to keep its low-velocity, high-explosive weapon. The academic theory had to be protected at all costs. But military theories rarely survive the violent, unpredictable friction of actual combat. The true test of McNair's segregated armored doctrine would not happen on a training range in Texas, but in the desolate, rocky terrain of North Africa. In November 1942, the United States launched Operation Torch, landing thousands of untested American troops on the coasts of Morocco and Algeria. By February 1943, the advancing American forces found themselves stretched thin across the deserts of Tunisia, facing the battle-hardened veterans of Field Marshal Erwin Rommel's Afrika Korps. At a remote, narrow gap in the Atlas Mountains known as Kasserine Pass, the theoretical tank-destroyer doctrine violently collided with reality. The German military did not play by McNair's rules. When the Afrika Korps launched their armored offensive, they did not attack in a way that allowed the American tank destroyer battalions to form up and execute their carefully planned ambushes. The battle space was chaotic. Communication lines broke down. In the confusion, American commanders on the ground were forced to ignore the field manuals entirely. The high-speed M10 Wolverines and specialized anti-tank half-tracks were not deployed as a concentrated reserve force. They were broken up into tiny, isolated packets and fed piecemeal into the defensive lines to plug sudden gaps. When the German Panzerkampfwagen 4 Specials, equipped with heavily reinforced frontal plates and lethal, long-barreled 75mm guns, rolled through the dust, the American defenses collapsed. Think about what that tactical failure actually meant for the crews caught in the middle of it. The specialized tank destroyers, forced into static defensive positions, found that their thin armor and open-topped turrets offered absolutely no protection against high-explosive artillery airbursts or direct kinetic strikes. Meanwhile, the American tank crews operating the older M3 Lee and the newer M4 Sherman suddenly found themselves face to face with advanced German armor. The strict division of labor evaporated. Sherman crews had no choice but to engage the heavier panzers directly. The engagement math was heavily skewed against them. The low-velocity 75mm guns of the American mediums struggled to achieve penetration against the upgraded German armor at combat ranges, while the German high-velocity weapons effortlessly punched through the American structural plates. The resulting combat at Kasserine Pass was a severe tactical defeat. American armored forces suffered incredibly heavy losses, with dozens of vehicles neutralized and entire defensive lines overrun. The structural and ballistic realities had completely dismantled the academic theory. In the aftermath of the battle, frantic after-action reports flooded back to the Pentagon. Frontline commanders in North Africa were practically screaming for heavier armor and bigger guns. The ordnance engineers seized upon these reports, presenting the data as undeniable proof that the enemy was fielding highly capable tanks that required an immediate, heavy American response. They pleaded with the War Department to authorize the mass production of heavier designs and to permanently abandon the restriction on upgunning the Sherman fleet. Surely the shocking loss of American armor and the complete breakdown of the tank destroyer concept at Kasserine Pass would be enough to convince General McNair that his tactical vision was fatally flawed. It was not. In a staggering display of bureaucratic stubbornness, McNair reviewed the casualty reports from North Africa and drew the exact opposite conclusion. He did not blame the doctrine. He blamed the commanders on the ground for failing to execute the doctrine properly. He argued in official memorandums that the tank destroyer units had suffered heavy losses simply because local generals had improperly dispersed them, rather than concentrating them as the manuals dictated. To McNair, Kasserine Pass was a failure of discipline, not a failure of engineering. He doubled down, successfully maintaining his blockade against the mass production of heavy American tanks and keeping the high-velocity guns off the M4 Sherman assembly lines. The dissenting engineers were trapped, buried under the immense weight of the War Department bureaucracy. If the highest-ranking general in charge of ground forces completely refused to acknowledge the ballistic reality of the battlefield, who could possibly force a change before the impending invasion of mainland Europe? While McNair defended his rigid, segregated manuals from the safety of Washington, a vastly different philosophy was brewing in the field. A highly vocal, incredibly influential field commander had watched the exact same combat operations in North Africa and formed a completely different set of conclusions. He did not care about McNair's academic rules, and he certainly did not want the sluggish, heavy tanks pushed by the Ordnance Department. He wanted speed, he wanted reliability, and he believed that massive operational tempo could overcome any thickness of German steel. His fierce, unwavering defense of the 30-ton Sherman was about to create an entirely new set of strategic complications for the Allied advance. Enter General George S. Patton. To understand why the American military deliberately stalled the development of heavier armor, you have to look closely at the man who would become the most vocal, influential champion of the medium tank. Patton was not a desk-bound academic like General McNair. He was a combat-tested cavalryman who viewed mechanized warfare strictly through the lens of pursuit, exploitation, and relentless forward momentum. When Patton looked at the M4 Sherman, he did not see an undergunned, vulnerable machine that required immediate replacement. He saw an engineering masterpiece perfectly optimized for his specific style of maneuver warfare. To Patton, A tank was essentially a horse made of steel and cast armor. In his operational philosophy, a tank's primary weapon was not its cannon, it was its engine. He believed fiercely that the true purpose of an armored division was to bypass heavily fortified enemy strongpoints, sever communication lines, and strike deep into the unprotected logistical rear of the enemy formation. For this kind of deep penetration doctrine, you needed a vehicle that could drive for hundreds of kilometers without stopping. Stay with me here, because this is where the engineering reality perfectly aligns with Patton's operational vision. The 30-ton M4 Sherman was an absolute marvel of mechanical reliability. Early models were powered by massive aircraft-derived radial engines, and later variants utilized incredibly robust Ford V8 power plants. The power was delivered through a synchronized, constant mesh transmission located at the front of the hull. If a transmission failed in the field, an American recovery crew could unbolt the entire front armor housing, slide the broken unit out, drop a new one in, and have the tank back in combat operations in under 24 hours. Compare that to the heavy German armor beginning to appear on the battlefields. Vehicles like the Panzerkampfwagen, 6 Tiger were engineering marvels in terms of ballistics, but they were operational nightmares. Weighing in at over 50 tons, the Tiger placed immense, unsustainable strain on its final drives and complex interleaved road wheels. If a heavy German tank snapped a transmission deep behind enemy lines, it often required 2 other heavy recovery vehicles just to tow it back to a specialized repair depot. German armored units routinely suffered severe drops in combat readiness simply due to mechanical exhaustion during long road marches. Patton knew this. He prioritized high operational tempo above all else. He wanted his armored divisions to maintain a state of constant, aggressive motion. An M4 Sherman could drive thousands of kilometers on a single set of rubber block tracks. Its engine rarely overheated, and its suspension systems could absorb massive punishment over broken terrain. To Patton, a 60-ton heavy tank with impenetrable frontal armor was entirely useless if it broke down 20 kilometers before it ever reached the front line. But mechanical reliability was only one half of Patton's argument. Think about the logistical footprint required to keep an armored division moving across a continent. The United States Army was operating at the extreme end of the longest supply chain in the history of warfare. Every single liter of high-octane fuel, every artillery shell, and every spare part had to be trucked in from coastal ports. A heavy tank is a logistical black hole. It consumes massive amounts of fuel per kilometer, demanding an endless convoy of soft-skinned supply trucks just to keep its engine running. The M4 Sherman was significantly more fuel efficient, allowing Patton's columns to stretch their supply lines to the absolute breaking point and outrun the enemy's ability to retreat. Furthermore, the weight of the vehicles directly dictated where they could actually travel. The European continent is scarred with thousands of rivers, streams, and deep ravines. When retreating enemy forces blew up the stone bridges behind them, Allied combat engineers had to rapidly deploy portable steel Bailey bridges to keep the advance moving. These temporary modular pontoon bridges had strict weight classification limits. A 30-ton medium tank could roll across a standard pontoon bridge without hesitation. A 60-ton heavy tank would easily exceed the structural load limits, collapsing the bridge into the river and halting the entire division's advance until specialized heavy-duty infrastructure could be built. Patton used these precise logistical metrics to wage his own bureaucratic war against the Ordnance Department. When engineers presented him with drafting concepts for heavily armored, heavily armed tanks, Patton famously rejected them in official memorandums. He argued that the heavy tank was a sluggish, gas-guzzling liability that would only tie his fast-moving divisions to the muddy roads and reinforced stone bridges of Europe. In a strange, unintended alliance, Patton's pragmatic field arguments perfectly reinforced General McNair's academic theories. Both men, for completely different reasons, were actively suppressing the mass production of heavy American armor. But what about the inevitable combat encounters with heavy enemy tanks? Patton did not ignore the threat. He simply believed he had a tactical solution. If an American armored column encountered a heavily armored German defensive line, Patton's doctrine dictated that they should not engage in a static, head-to-head slugging match. That was a mathematical losing proposition. Instead, he relied on superior speed and mass flanking maneuvers. The Sherman had a distinct mechanical advantage in close-quarters maneuvering. It was equipped with a hydraulic, power-operated turret traverse mechanism that could rotate the main 75mm gun a full 360 degrees in approximately 15 seconds. A heavy German Tiger, relying on an engine-driven traverse that was tied to its RPMs, could take a full minute to complete the same rotation. Patton believed that a platoon of fast-moving M4 Shermans could use smoke, artillery cover, and their rapid turret speed to simply swarm a heavier enemy vehicle, maneuvering around to its vulnerable sides and rear engine deck, where the armor was substantially thinner. If flanking was impossible, they were to bypass the heavy armor entirely, driving around the strong point and cutting off the enemy's fuel and ammunition supply lines. It was a brilliant operational strategy, perfectly suited for the wide-open deserts of North Africa and the rolling hills of Sicily. But deeply troubling intelligence was beginning to filter into the Pentagon that threatened to completely unravel Patton's confidence in the medium tank. Far to the east, the Soviet Union was engaged in a brutal, mechanized war of attrition against the bulk of the German military. In the summer of 1943, during the massive armored clashes around Kursk, Soviet intelligence officers began documenting the mass deployment of a completely new generation of German armor. They captured several intact models of the Panzerkampfwagen 5 Panther and immediately forwarded the technical specifications to American military liaisons. When the US Ordnance engineers reviewed the Soviet data, alarm bells rang through the department. The Panther was not a specialized, limited production, heavy breakthrough vehicle like the Tiger. It was specifically designed by German engineers to be a mass-produced medium tank replacement. It featured 80 millimeters of frontal armor, steeply sloped to artificially increase its relative thickness and ballistic deflection capabilities. Worse still, it was armed with a highly lethal, extremely high-velocity, 75mm anti-tank gun. The American ballistics experts ran the math, and the results were grim. The standard M4 Sherman, armed with its low-velocity 75mm cannon, would not be able to penetrate the front of a Panther at any standard combat range. The kinetic energy simply was not there. Conversely, the high-velocity gun on the Panther could easily punch cleanly through the front of a Sherman from well over 1,000 meters away. This intelligence fundamentally changed the strategic landscape. The ordnance engineers realized that the American armored divisions were not just going to face a handful of heavy Tigers. They were going to encounter thousands of highly advanced Panthers. The argument that American tanks could simply use their speed to flank the enemy began to sound like a desperate gamble rather than a sound military doctrine. If the enemy was mass-producing vehicles with impenetrable frontal armor, the U.S. Army urgently needed a tank with a high-velocity 90-millimeter gun that could achieve direct frontal penetrations. Despite frantic warnings from the engineers analyzing the Eastern Front data, the command structure refused to pivot. Patton's towering operational successes and McNair's rigid control over procurement effectively locked the American industrial machine into churning out the standard Sherman. The doctrine of speed, reliability, and infantry exploitation was too deeply entrenched. But geography dictates strategy, and the wide-open spaces of the Mediterranean theater were about to be left behind. As military planners began drawing up the final invasion routes for the D-Day landings, they looked at the maps of the Normandy countryside. It was not open desert. It was a claustrophobic, ancient landscape defined by high earthen embankments, sunken roads, and dense hedgerows. It was an environment perfectly suited for heavily armored defensive ambushes, where flanking maneuvers would be geographically impossible. How long could Patton's brilliant operational tempo mask the mathematical reality that his tanks could not survive a direct hit? As the invasion fleet prepared to cross the English Channel, a rogue faction of desperate engineers deep inside the Pentagon realized that the entire doctrinal framework was walking into a slaughterhouse, and they decided to take matters into their own hands. While the theoretical debates over armor doctrine echoed through the pristine halls of the War Department, the physical reality of the Italian campaign was rapidly tearing the official narrative apart. In late 1943, Allied forces pushed into the mountainous, deeply contested terrain of the Italian peninsula. This was not the open, sweeping desert of North Africa, nor was it the rolling, wide-open plains of the American training grounds. It was a rugged, vertical landscape defined by narrow mountain passes, ancient stone villages, and muddy, washed-out roads. The wide, high-speed operational maneuvers favored by cavalry commanders were completely nullified by the geography. American armored columns found themselves funneled down confined roadways, forcing them into direct, head-to-head engagements with heavily entrenched German defensive positions. The tactical environment demanded a vehicle that could absorb a direct kinetic strike and return overwhelming firepower against fortified concrete and heavy steel. The 30-ton M4 Sherman, armed with its low-velocity 75-millimeter gun, was structurally and ballistically entirely unsuited for this brutal war of attrition. Frantic after-action reports and desperate procurement requests from frontline commanders in Italy flooded into the Pentagon, explicitly asking for heavy armor capable of surviving static, frontal engagements. Back in the United States, a rogue faction inside the Ordnance Department was watching these combat reports with mounting alarm. Under the direction of Major General Levin H. Campbell, the Chief of Ordnance, the engineering staff had already anticipated this exact tactical crisis. For months, they had been quietly pouring their resources into a highly classified, heavy tank program designed specifically to shatter the advanced German defensive lines. It was officially designated the heavy tank T-26. Stay with me here because understanding the specific engineering parameters of the T-26 reveals exactly how capable the American military machine truly was when it discarded its self-imposed doctrinal handicaps. The T-26 was a radical departure from everything the United States had fielded up to that point. It abandoned the tall, highly visible, narrow-tracked profile of the standard medium tanks. Instead, it was engineered with a low silhouette, a wide track stance, and a highly advanced independent torsion bar suspension system. Think about what that mechanical reality actually meant for its mobility. By utilizing internal torsion bars rather than the external volute spring suspension found on the Sherman, engineers allowed the road wheels to travel much further vertically. This smoothed out the ride over broken terrain and provided a vastly superior, stable firing platform. More importantly, it allowed the engineers to fit exceptionally wide tracks to the vehicle. Even though the T-26 tipped the scales at an immense 42 tons, the wide tracks distributed that weight so efficiently that its actual ground pressure was nearly identical to the lighter 30-ton Sherman. It would not sink into the European mud. But the true operational value of the T-26 was its lethality. It featured a massive, exceptionally thick cast steel turret designed explicitly to house a high-velocity M3 90mm anti-tank gun. Look at the physics of this engagement. The standard American 75mm armor-piercing projectile struggled to maintain sufficient kinetic energy to breach heavy German armor, even at close ranges. The M3 90mm gun completely changed the ballistic math. Firing a massive armor-piercing capped projectile at over 800 meters per second, the weapon generated an immense amount of kinetic energy upon impact. For the first time, an American tank crew would have the capability to punch cleanly through the 80mm, highly sloped frontal plate of a German Panther from over 1,000 meters away. They would not need to rely on complex, highly coordinated flanking maneuvers. They could simply point, fire, and achieve complete tactical elimination of the heaviest enemy targets on the battlefield. General Campbell and his ordnance engineers knew this vehicle was the exact kinetic solution the front line urgently required. Armed with the irrefutable combat data from Italy and the intelligence reports detailing the mass production of the German Panther, the Ordnance Department drafted an immediate procurement request. They petitioned the War Department to authorize the mass production of 7,000 T-26 heavy tanks, intending to flood the impending European theater with vehicles capable of absorbing punishment and returning it in equal measure. They ran straight into the immovable bureaucratic wall of Army ground forces. Lieutenant General Leslie J. McNair viewed the T-26 not as a technological breakthrough, but as a direct, unacceptable threat to his entire segregated tactical framework. If you gave frontline armored divisions a heavily armored tank equipped with a massive 90mm gun, they would naturally use it to engage and hunt enemy armor. That directly violated his strict division of labor. The academic doctrine still officially mandated that only the specialized, lightly armored tank destroyer branch was permitted to hunt tanks. The medium tanks were supposed to exploit infantry breakthroughs. Here is where the bureaucratic friction escalated into absolute institutional sabotage. Look at what the declassified internal memorandums reveal about this power struggle. McNair actively suppressed the heavy tank program by weaponizing the logistical data of the global supply chain. He pulled shipping constraints, fuel consumption estimates, and combat pontoon bridge load limits to argue that the T-26 was an operational liability. He claimed that a 42-ton vehicle would completely snarl the transatlantic supply lines, consume too much high-octane aviation fuel, and snap the structural cables of standard cargo ship cranes. McNair completely ignored the engineering data, proving that the wide tracks of the T-26 mitigated its ground pressure, and he deliberately dismissed the verified intelligence regarding the thick frontal armor of the new German Panthers. In a stunning official memorandum sent back to the Ordnance Department, McNair explicitly stated that the M4 Sherman had been hailed as the greatest tank on the modern battlefield, and that he saw absolutely no requirement for a heavier vehicle. Using his unparalleled bureaucratic authority over ground forces equipment, McNair officially vetoed the urgent request for 7,000 vehicles. But he did not stop there. He systematically downgraded the production orders to ensure the vehicle would never see mass deployment. He reduced the initial production authorization to a mere 250 units. Furthermore, in a final attempt to protect his academic tank destroyer theory, McNair explicitly ordered that even those few heavy prototypes should only be built equipped with the standard low-velocity 75mm gun, deliberately attempting to strip the heavy tank of its sole ballistic advantage. When the ordnance engineers fiercely pushed back against this absurd restriction, pointing out that mounting a short-barreled gun on a 42-ton chassis defeated the entire purpose of the vehicle, the resulting bureaucratic gridlock effectively stalled the entire assembly line. Heavy tank production was reduced to a microscopic trickle, lost in a maze of endless committee reviews and doctrinal arguments. But that deliberate bureaucratic blockade was about to violently collide with a geographical reality that the military planners in Washington were dangerously underestimating. The largest amphibious invasion in human history was rapidly approaching. When intelligence officers mapped the final inland push from the beaches of Normandy, they were not looking at open plains, and they were not looking at mountain passes. They were looking at the bocage. The Normandy countryside was partitioned by thousands of ancient hedgerows. These were not simple garden bushes that a tank could effortlessly crush under its tracks. They were massive, centuries-old earthen embankments created by medieval farmers who had piled stones and dirt at the edges of their fields for generations. Over centuries, a dense matrix of thick tree roots had bound the soil into concrete-like walls, topped with impenetrable, towering vegetation. The roads running between these hedgerows were sunken deep into the earth, creating narrow, confined corridors that completely restricted off-road movement. Think about the operational mechanics of attempting to maneuver an armored division through that specific environment. The high-speed flanking maneuvers, championed by cavalry commanders like General Patton, would be physically impossible. You cannot swarm an enemy's strong point or maneuver to their vulnerable rear engine deck if your vehicles are trapped in a single-file line between 6-foot walls of solid earth and timber. The fast hydraulic turret, traverse mechanisms, and highly reliable engines of the standard M4 Shermans meant absolutely nothing if the tanks could only advance straight down a narrow, predetermined lane. German defensive units recognized this immense geographical advantage immediately. They knew the terrain funneled American columns into highly predictable choke points. The standard tactical engagement range, which military planners had assumed would be over 1,000 meters, suddenly shrank to less than 100 meters. At that point-blank distance, the physics of the engagement became a nightmare for the lightly armored American mediums. German commanders positioned their heavy armor and highly concealed, high-velocity anti-tank cannons at the exact ends of these narrow corridors. When an American armored column advanced, they would be forced into a lethal bottleneck. The lead vehicle would take a direct kinetic strike from a concealed 88mm or 75mm gun. The sheer velocity of the German weapon at that short range meant the armor-piercing shell would not just penetrate the Sherman's 51mm frontal plate, it would often over-penetrate, causing catastrophic structural compromise and instant ignition of the internal ammunition stores. Once the lead tank was neutralized, it became a burning roadblock. The thick hedgerows on either side prevented the rest of the column from maneuvering off the road to return fire or bypass the ambush. The entire tactical philosophy of speed, reliability, and infantry exploitation was walking directly into an environment perfectly engineered for static, heavy armor defense. Deep inside the Pentagon, the dissenting ordnance engineers analyzed the aerial reconnaissance photos of the French countryside and ran the grim tactical simulations. The mathematical results pointed toward a massive operational failure. They knew with absolute certainty that sending thousands of lightly armored, undergunned medium tanks into the bocage without heavy kinetic support would result in extreme losses for the frontline crews. The academic field manuals drafted in Texas and the cavalry pursuit theories tested in the open desert were about to be rendered entirely obsolete by the confined, brutal spaces of Normandy. The engineers realized they were completely out of time. The invasion fleet was already assembling across the English Channel, with the highest echelons of the ground command strictly refusing to acknowledge the imminent ballistic reality, and General McNair maintaining an iron grip over the official procurement channels. The Ordnance Department had to make a desperate, highly unorthodox choice. If the official chain of command would not listen to the intelligence, the engineers would have to find a way to subvert the entire military bureaucracy. They needed to completely bypass McNair's blockade and smuggle the heavy 90-millimeter kinetic firepower of the T-26 directly to the front lines before the American armored divisions were fed into an unavoidable tactical catastrophe. The moment the landing craft dropped their ramps on the coasts of France in the early summer of 1944, the academic theories drafted in the pristine offices of the War Department simply evaporated. The sprawling, high-speed flanking maneuvers, envisioned by the highest echelons of the military command, were instantly nullified by the dense, ancient hedgerows of the Normandy bocage. The geography forced the exact engagement geometry the dissenting ordnance engineers had simulated and feared. American armored columns were funneled into narrow, deeply sunken roads, completely stripping the M4 Sherman of its primary tactical advantage: mobility. Instead of operating in the expansive enemy rear to disrupt supply lines, the frontline crews found themselves trapped in a brutal, static war of attrition. The engagement distances shrank from over 1,000 meters down to mere dozens of meters. At point-blank range, the highly concealed German high-velocity anti-tank weapons operated with immense lethal efficiency. A single kinetic strike from a hidden 88-millimeter gun meant an immediate, fatal outcome for the American vehicle. General McNair's strictly segregated tank destroyer battalions, designed to act as a highly mobile, mechanized fire department, were rendered entirely ineffective. They could not rush to plug gaps or execute sweeping ambushes because they could not maneuver off the confined roadways. The strict division of labor collapsed. The medium tanks had to fight the heavy enemy armor directly, and they had to pay a staggering price in machinery and personnel to clear every single field. The crews operating the M4 Sherman did not wait for the War Department to resolve its bureaucratic gridlock. Recognizing that the official procurement channels had failed to provide them with survivable heavy armor, they took matters into their own hands. A massive, unsanctioned wave of field engineering swept through the frontline maintenance battalions. If Washington would not send heavier tanks, the crews would simply build them out of whatever materials they could scavenge from the battlefield. Maintenance units deployed heavy cutting torches to slice the thick frontal plates off neutralized German panzers, welding that heavy Krupp steel directly onto the glacis plates of their own Shermans. When steel plate was unavailable, they improvised with raw mass. Crews constructed intricate wooden or steel racks on the front and sides of their hulls, stacking hundreds of heavy canvas sandbags against the structural plates. Others created makeshift wooden molds and poured thick layers of solid concrete directly over the transmission housings and lower hulls. Think about the profound mechanical irony of this situation. The primary argument utilized by the top military brass to suppress the heavy tank program was that increased weight would severely damage the logistical chain, overload the suspensions, and cause massive operational delays. By bolting tons of scrap steel, wet sand, and solid concrete onto a 30-ton chassis designed for high-speed pursuit, the American crews essentially created unsanctioned, heavy tanks in the field. This added immense, completely unplanned stress to the Ford V8 engines and the external volute spring suspension systems. The extra weight drastically accelerated track wear, caused the narrow tracks to sink deeply into the European mud, and frequently resulted in catastrophic transmission failures. Worse still, from an engineering perspective, these field modifications provided almost no actual ballistic protection against the primary threat. The math of kinetic energy dictated that a high-velocity, armor-piercing projectile, capped with a hardened steel penetrator, would easily punch straight through layers of sandbags or concrete before slicing through the base armor of the tank. The improvised armor was almost entirely a psychological shield. It gave the crews the mental endurance to climb back into their vehicles and continue the advance, even while the fundamental ballistic reality remained unchanged. If the confined spaces of Normandy fractured the official doctrine, the bitter winter of 1944 completely shattered it. When the German military launched their final, massive counteroffensive through the frozen forests of the Ardennes, they pushed concentrated spearheads of highly advanced, heavy armor directly into the American defensive lines. Heavy cloud cover grounded the Allied air support, stripping the American ground forces of their primary method of neutralizing the heavy panzers. The specialized tank destroyer units, stretched dangerously thin across a massive front, and unable to operate as the concentrated reserve force the field manuals demanded, were completely overwhelmed by the sheer mass of the German armored thrust. The M4 Sherman crews were forced to hold the line against machines that vastly outclassed them in both frontal armor and kinetic firepower. The resulting combat operations during the Battle of the Bulge forced the American armored divisions to absorb exceptionally heavy losses. Entire tank platoons were tactically eliminated simply because their low-velocity 75mm guns could not achieve penetration against the advancing German heavy tanks. The sheer volume of the after-action reports and the undeniable physical reality of the heavy equipment losses finally reached a critical mass inside the Pentagon. The frontline commanders could no longer be ignored or overruled by academic theories. The bureaucratic blockade against heavy American armor was permanently broken. Major General Levin H. Campbell and the Ordnance Department seized the moment, entirely bypassing standard, sluggish procurement channels. They initiated the highly classified Zebra mission, an emergency logistical operation designed to rush the heaviest American kinetic firepower directly to the European theater. The advanced T-26 heavy tank, now officially standardized and designated as the M26 Pershing, was rapidly loaded onto transport ships and sent across the Atlantic. When the massive 42-ton vehicles finally rolled onto the combat zone in the early months of 1945, the tactical geometry shifted almost immediately. Armed with the high-velocity M3 90mm gun, American crews finally possessed a machine engineered to engage heavy German armor frontally. They could achieve complete structural penetration of enemy targets from well beyond 1,000 meters. During the rapid Allied push toward the Rhine River, the M26 Pershing demonstrated its immense capability, decisively neutralizing heavily armored defensive positions that would have easily repelled a standard Sherman. Look at what the field data proved regarding the engineering parameters. The advanced independent torsion bar suspension and the exceptionally wide tracks functioned exactly as the ordnance engineers had promised. The 42-ton vehicle did not sink helplessly into the mud, and it successfully crossed the temporary combat pontoon bridges without snapping the structural cables or collapsing the infrastructure. The logistical arguments used to suppress the heavy tank for years were proven physically incorrect on the actual battlefield. But the arrival of the M26 Pershing occurred far too late to fundamentally alter the tactical landscape of the conflict. Only a few hundred models saw active combat operations before the cessation of hostilities. By the time the heavy armor was deployed in meaningful numbers, the overarching industrial war of attrition had already been decided. Here is where the great historical paradox resolves into a deeply complex, uncomfortable reality. Post-war engineering analysis and strategic reviews confirmed a staggering truth. The very doctrine that deliberately handicapped the frontline American tank crews is exactly what guaranteed the ultimate logistical victory. The German military produced vastly superior, heavily armored machines designed for individual battlefield dominance, but their immense weight, over-engineered mechanical complexity, and constant need for specialized heavy recovery vehicles caused massive mechanical failure rates and completely strangled their own supply lines. Meanwhile, the American strategy of standardization created a tidal wave of mechanized armor. By freezing the design and strictly prioritizing mass production, American factories churned out nearly 50,000 M4 Shermans. Even if individual vehicles were highly vulnerable and routinely lost in direct combat, the logistical chain was so incredibly robust that a replacement tank was almost immediately available to take its place. The high mechanical readiness and unparalleled reliability of the medium tank allowed the Allied forces to achieve an operational tempo that simply drowned the heavier, slower German forces under sheer numbers. The United States did not win the armored conflict in Europe through superior ballistics or impenetrable frontal steel. They won it through overwhelming industrial efficiency and the sheer volume of their supply chain. The fierce debate among historians, military tacticians, and engineering analysts remains unresolved to this day. Was the strict adherence to the M4 Sherman a brilliant, necessary, strategic compromise of industrial warfare that recognized logistics as the ultimate arbiter of victory? Or was it a fatal, bureaucratic stubbornness rooted in flawed academic theories that needlessly forced thousands of American tank crews into a severely uneven fight? The physical legacy of that decision remains cast in the thousands of tons of steel left scattered across the European continent.